Hello and welcome back. This is a very important segment on arrays. All modern languages will have this concept, and it adds a lot of power to the programs that you can write. We're going to need to store multiple pieces of data in a single variable, and that is used very commonly in programming in all languages. So let's have a look now at the concept of arrays.
Okay, let's start talking about arrays now. First of all, I want to motivate the need for having something called an array. So let's suppose that we want to have a program that extends our previous programs where we were collecting test scores, and we want to average all of the test scores. But in this case, we're going to have a lot more. So suppose we had a lot more test scores that we wanted to process, and up until now all we could do is declare each one as an individual variable. So we would give it a data type, in this case int, and each one would have its own name, grade 1, grade 2, and so on. Well, this would be really a tedious thing to do if we had 100 of them, or if we had 1,000 of them. We would never get finished just declaring the arrays, or the variables, and processing those variables would be a very painful way of coding. So what we need is a way to store lots of values in one variable, excuse me, and this will be called an array. So on this slide we have a picture of what an array in memory might look like. So we have a variable called grades, and we have 10 different grades in that one variable. And this is the concept of an array. So we need a way of declaring an array in the C language, and we're going to use the square brackets. So here's a declaration of the array grades. The data type is int, and the name of the array is grades, and it's indicated to have 10 variables, and we must use those brackets to declare an array in C. So we call the elements of an array, the grades, the individual grades in the array will be called the elements of the array, and we're going to access those individual variables, the elements, using a subscript or an index into the array to indicate which of the elements we want to use. So, for example, the first one in the array is grades sub 0. So this is the first thing to remember about an array. In C, the first one is always at subscript or index 0. If we have an array of 10 elements, the subscripts range from 0 to 9. Each of the elements can be used the same as you would use an int variable. So grades sub 0 gets 75, means put 75 in that first box in the array. Grade sub 1 gets grade sub 0 plus 15. So what goes in the box grade sub 1? We're going to take the value that was in grade sub 0, which is 75, add 15 to it, and 90 will go into the variable grade sub 1. So we have subscripts, which are integer values that allow us to indicate which of the particular elements in the array we want to be talking about now. On this slide, we look at how you might initialize an array at the same time you declare it. And in this first example, we have the same declaration that we had before, int grades sub 10. That means that we'll have 10 elements in this array. And we can initialize it using the braces and a list of numbers that would go into the elements of the array. So with this declaration, including the initialization, we would have 75 in the 0th place, and 90 in the first place, and 87 in the third place, and so on. The next declaration is the more common form that we would see we don't usually have all of the data that we want to put into an array at the time we declare it. So what we might want to do is to set all of the elements in the array to 0. You remember that when you declare a variable, there is nothing in that variable. There's actually junk in the variable at the time you declare it, and that sometimes can cause problems. So we would want to often initialize all the elements of the array at the same time, the same way you would initialize a variable to 0. For example, a counter has to be set to 0 before you start adding 1 to it. So you don't have to put 10 zeros there, you can just put 1, and if you don't put enough values to fill up all of the array, excuse me, then C will automatically fill all the rest in with zeros. So here are some things to remember about the declaration of arrays in C. First of all, you can't change the size of an array after it's declared. So this array of 10 elements that we've declared will always have 10 elements in it. If you need more than 10, you're out of luck. You should have used a bigger number in the declaration. And the size of the array must be a positive number. So it wouldn't make sense to say, I want -5 elements in this array. So when you declare it, you are required to put a positive number. And it must be an integer number. It wouldn't make sense to have 2.5 elements in your array. So a positive integer number. And the size of the array, when you declare it, it must be a constant, not a variable. So it could be a defined constant, which we'll look at, or a literal. In this case, we use the number 10, which is a literal. When you're using the elements of an array, the index that you choose obviously must be a positive integer. When you select which of the elements you're talking about, you can use 0 through 1 less than the size of the array. So in an array of 10 elements, you can have the name of the array, sub, which is the square brackets, 0 up to 9 for an array of 10 elements. It always helps when you're solving problems with arrays to draw a picture of the array that you're working with, so that as you're writing the code you can imagine, well, you don't have to imagine, you can just look at the paper and see what the values are that you're working with. So here's the defined constant that I talked about. It's very common in C language that you would define a constant that can be used throughout the program, especially when you're declaring arrays. So if we say pound define size to be 20, then we can use the size, capital S-I-Z-E, in the declaration of an array. So this means we have an array of double values called rainfall, and there are 20 elements in this array. The reason to use this defined constant is so that later on, if we want to change our program, we could just go up to the top, change that 20 to a 50 or 100, and all of the occurrences of the defined constant size would be changed to the new value. This is just, it's kind of for convenience and maintainability. You don't want to run through the program looking for 20 different places where you've used the number 20 and try and change them all without making a mistake. So we define that once at the top, and then we can use it throughout the program. It makes your code really easy to work with. Okay, let's look at a code snippet now where we would access the elements of an array using repetition. If we declared an array and we said, well, now we have to say grade sub 0 gets something and grade sub 1 gets something, we wouldn't have gained all that much. And we can use a loop to access all of the elements of the array one at a time. In this first example at the top, we declare an array called grades that has 10 elements, where each element is an int. We declare another variable called I. This is about the only time you get away with making a variable that has one letter. So when you use the variable I, everyone knows that this means index, or usually an index into the array. So look at this for loop now. It goes where I is 0 and I is less than 10, I++. So this loop executes when the value of I is 0 through 9. And this is the most common way of using a loop to access the elements of an array. You go from 0 to less than the size, so that the last value of the index is 9 in this case, or 1 less than the size of the array. Remember that there is no grades sub 10 in this array, even though it looks like there might be because you declared there to be 10 elements in the array. In the second example, down below the dashed line, we have an array of double elements called rainfall, and it's declared to have 20 elements in it. So 20 is size rather is a constant, a defined constant. It's not a variable. So you can't have a variable sized array in C. And here's the for loop that does something with each elements of the array. We have the exact same format, a variable I that goes from 0 to less than the size of the array. So we're using the defined constant in the for loop as well as in the declaration. This loop seems to want us to ask the user to fill up the elements of the array by asking the user to enter the values. So we're asking the user enter the next rainfall figure, and then we scan in the elements one at a time into the ith location. So the first time through this loop, I will be 0, and we'll enter the 0th element. And the next time through the loop, I will be 1, and we'll have rainfall sub 1. So this is where people find this tricky. We have one variable, rainfall, and we have another variable, I, and those are used in conjunction to access the elements of the array. Rainfall sub I is a different variable depending on what I is. So this is common for loop, 0 to less than the size of the array, that would access each of the elements of the array. I'm going to introduce the concept of two-dimensional arrays here. This might be just a little bit advanced for this class, but we'll have a look anyway. An array that has one dimension is sometimes called a list, and an array that has 2 dimensions is sometimes called a table. So a table is a 2-dimensional array, and we would think of these as rows and columns. This particular array, where each element in the array is an int, has 10 rows and 5 columns. So we might think of this as the rows representing students and the columns representing grades. So if you had 5 different grades, your row in this table would contain all of your grades. If we looked down to one of the particular cells or elements in this table, we might say all grades sub 6 sub 3 gets 99. So we would count down the rows 0, 1, 2, 3, 4, 5, 6, that's the 7th row, and we would count across 0, 1, 2, 3, that's the 4th column, and put 99 in that cell. Two-dimensional arrays are not too foreign to students. Usually people are familiar with a game called Battleship, where you have a grid like this with rows and columns, and you call out the cell that you want to play in this game? I don't know exactly how to play that game, but it looks very much like a two-dimensional array. I think what we'll do now is we'll go into the development environment and we'll look at the declaration of arrays and we'll play with arrays. In this case, not to do problem solving, just to get comfortable with the concept, and we'll look at problem solving in the next segment. Okay, here we are in the Visual Studio, and I'm going to record this one with a slightly higher resolution. The feedback is that you don't need such a small screen, and you could see more if we use this resolution. So let's try it. So I'm going to create a brand new project, a Win32 console application, and I'm going to call this one Arrays Study. We will look at the concept of creating arrays, and this is, as usual, an empty project. Now in Array Study, I will add a new item, a C file, and I'll call it Array Study. Remember to put the .c there so that we don't wind up with a C++ file. So let's put the usual suspects. And if I put that brace up on that line, it will give us just a little bit more room to work. Okay, and the system pause down at the bottom will help us see what the program is doing when we run it so that it doesn't get away. Okay, so remember the reason that we would want to do this is because we don't want to declare 1,000 of these. That would take forever. We don't know how many grades we have sometimes. So I'll comment that one out. We don't want to declare our variables like that when we've got a lot of them and they're all the same data type. So what we want to do instead is to declare an array called grades, and using the brackets, let's say, like we did in the example, that we have 10 of them. So it's as easy as that. We now have 10 int variables, and they range from 0 to 9. Let's be optimistic. Let's put 100 in there. So what can we do with these array elements? Well, we can do anything that we could have done with a plain int. So we could output them. The first element is %i \n sub grades sub 0 has 100 in it. And if we run this, excuse me, we should find that it prints out that the first element in the array is 0. And it might be worth it to look at this array in the debugger while we're here. It always helps when people can visualize what the data is that they're working with. Let's put a breakpoint on the print statement and run up to that breakpoint. And what can we see here in the variables window? Here's the variable grades, and we can pop it open and see that the 0th element has 100 in it, and all the remaining elements have junk. So these large negative numbers aren't something that we would want to use. And notice for sure that it goes up to sub 9. So we have from 0 to 9 in the array. Now if we execute that, it should have printed out onto our screen. The first element is 100. Good. So far, so good. And let's allow that program to finish. So now let's go back and use the initializer. You don't have to initialize your arrays, excuse me, if you don't need to. But if we want to put a 0 in all of them before we start, we can do it this way with braces. So that will fill up the array with zeros. If we knew what values we want in the arrays, I better not put 12, that's a bad grade. 87, that's not a great grade either. There's an F. Okay, so this is grades sub 0 and sub 1, sub 2, and sub 3. The rest of the array, using this initializer, would be filled in with zeros. So if you don't specify enough values in the initializer, you would have the rest with zeros. Well, let's prove that. Let's see what's in all the elements of the array by making a for loop that would loop through the array. So I need a variable I to do this, a control variable for the for loop. So I gets 0, I is less than 10, I plus plus, and I'm going to print out the elements of the array. And I'll print element %i. I'll output the index as %i and the value in the index, \n. Don't get the i's mixed up. The %i is not the variable I. It's just the % sequence that printf needs to understand that you're printing out an int. So I'll print out the value of I in the first one and the value of grades sub I in the second one. So each time through this loop, we will have a different I, which means we'll have a different grades sub I. So let's just run this. I assume that it will work. So we initialized the elements. The first 4 had something in it, but the last ones didn't have anything in them, just the initial value of 0. I guess that is something in it. It had a 0 in it. Okay, so we should be starting to get comfortable with the concept of an array here. This as an array of ints using the square brackets. This is the initializer. You use the braces and comma separated values for the initializer. And when you have an array, you can use each element of the array as if it were one of those things. So each element in this array is a simple int variable. When you want to do something with the values in the array, you have to do something one by one. You can't say, I want all of the elements in the array to have 64. You just can't do that. There isn't any way. So you have to make one of these loops that says, go through each element of the array using a control variable or an index that varies from 0 to 1 less than the size of the array. Well, I hope you're typing along with this because it does make it a lot easier if it actually comes off of your fingers. Okay, we're going to define a constant up here. So pound define size, and in the example I think we used 20. So this time we're going to declare another kind of an array. We'll declare an array of double values. So each element in this array will be a double. So it looks like we're going to collect some rainfall amounts. Now I don't know if you'll remember this or not, but this size identifier is not a variable. It's a defined constant. So here's the definition of size. Every time this identifier appears in the program, the precompiler will take this value and substitute it in. So this is not a variable in the language. It doesn't take up any space. It's just whatever is here is substituted for wherever that identifier appears. Not a variable, an identifier. When we define constants, we typically put them in all uppercase because it's easier to see what's going on. Here's a very common problem. If you put a semicolon here by mistake, what will happen? So we have a a compiler error. And let's look at what the compiler error is. It points at this line, and you can look at that line for a long time and say there is no compiler error there. And the problem isn't on that line. The problem is that 20 semicolon is being substituted for the identifier size. And you must put an int in here. You can't put a semicolon in there. So pound defines are a little bit tricky. If you do something wrong with them, the compiler will point out the wrong line has a mistake in it. So let's fix that and rebuild. There, we don't have any errors anymore. Okay, so we're going to use this defined constant instead of a constant literal like we did in the last one. We had the literal 10. So in this little code snippet where we use the double variable of the double array rainfall, I'm going to make a for loop. We can reuse the same variable I. I gets 0. I is less than size this time. That's the same as saying I is less than 20. I plus plus. And now we'll ask the user to enter a rainfall. I might put a space there. And then scanf. You know how to scanf works. You put a %lf and ampersand the variable that you want to read the value into. So we're going to read this value into rainfall sub I. So the first time through, I will be 0, and we'll read into rainfall sub 0. And why don't we just echo that back to the user to make sure that it seems to be working. So rainfall %I has %.2LF, and I'll put the \n there. We're going to output the value of the I and the value that the user just entered, rainfall sub I. That output statement doesn't really have any purpose except to help us have confidence that we know what's going on. And there's a bug right there. I meant to put a decimal point. Before we run this, I want to point out something that I know a lot of you are doing wrong. When you're doing a printf statement, you can format the output. So we put 0.2 here, indicating that we want 2 places past the decimal. When you're doing a scanf, you cannot format the input. There is no way of telling the user that you only want 2 places past the decimal. I suppose you could output a message saying that, but you cannot put 0.2 LF in a scanf, only in a printf. And that causes the scanfs not to work, and it's a pretty common bug. So let's run this program and start entering rainfall amounts and make sure that they're going into the right place. There's our integer example and a rainfall amount. Okay, 1.5. So rainfall sub-0 has 1.5. And just some random double values. 34.5, that's a lot of rain. 1.1. Oh, I typed 1.1, and look what it did. That's an interesting mistake. It took 1.0 as the first one, and then it didn't wait for me to enter another value on the next one, and it took 0.1. So the scanf, what we can learn from this now that it's happened by accident, the scanf is really a very fragile input mechanism. If the user doesn't do exactly what you want them to, then the program will do something unexpected. So if we entered letters here instead of numbers, well, I wonder what would happen. Oh, big problems. So it completely went into a loop, not knowing how to deal with the letters when we were doing something as simple as entering small double values. Okay. So let's just have a look before we leave this code window of the things that we've done. We declared an array of int variables that has 10 elements in it, and we used the initializer, the braces with the comma-separated values, and we declared an array of doubles using a defined constant as the size of the of the array of doubles. So each element in the array of grades is an int, and each element in the array rainfall is a double. Notice that the size of a double array has to be an integer. Is that making sense to you? You can't have 3.5 doubles. So you have to have an integer number of elements in all arrays regardless of what the data type. So we started experimenting with using the elements of the array, and we looked at this for loop, which is very important. This is you should be able to do this one in your sleep. I gets 0, I is less than the size of the array, I++. And then we made another for loop that used the defined constant as the stopping point, and we asked the user to enter the elements that would go into the array in this case, and then we just echoed them back to make sure that the values got into the right place.
And here's the concept summary for your segment on arrays. The first one is that the first index into an array in C is always 0. So if we have an array of 10 elements, the indices or the indexes into that array have to be 0 through 9. And there's a lot of time lost in going 1 through 10 for an array that has 10 elements. So watch out for that. A one-dimensional array is sometimes called a list, and a two-dimensional array is sometimes called a table. It's to help you visualize these things. And arrays can be of any data type. So the elements of the array can be of any data type that you choose, but the indexes into the array are always positive integers. So you don't have the 2.5 element and so on. The data type of the index is different sometimes from the data type of the elements themselves. Let's see, we have defined constants. Again, in this segment, they can make your program easier to maintain, and the defined constant we used specifically is the size of the array, so that you can change the size and that would impact the behavior of all of your loops and so on that manipulate the array. And here is a for loop that touches every element of an array, and you should be able to do this one in your sleep. The for loop that starts at 0 continues less than the size of the array and increments by 1. So that loop, and in particular the variable I, is very commonly used for manipulating each element of the array. That will also keep you from going off the end by 1. Okay, I hope you're enjoying learning about arrays, and we'll see you in the next segment.